characteristics of homologous series. So you will see that they have a general increase in the relative molecular mass. So if you work out the difference, 88 minus 74, that is plus 14. And then 102 minus 88, there's another plus 14, and you can do the same. And I can tell you they're all plus 14. Because what are you doing? You are adding CH2. You are adding CH2. You are adding CH2. You are adding CH2. Onto this, you insert a CH2 there. Right? Onto here, you insert another CO2 there. And so on. And so on. And you can go on. That's the meaning of the homologous series. Why are they plus 14? Because you are adding CH2. 12 plus 4 give you 12 plus 2. Because 2 hydrogen there give you 14. That's why you have an increase of 14. So there is a couple of characteristics of homologous series. But essentially you can see that each member vary or increase by CH2 increment, or basically increase by CH2 with increase in carbon. That give you a plus 14 difference in the relative molecular mass as stated there. Another thing that you can notice right away is that they have the same functional group. We are talking about the homologous series. We are talking about the ester homologous series here. So here, they are all ester. They are all ester because they contain the C double bond or group, or as shown there in the formula, there is the COO like that. But in actuality, when you draw it out, it's just ester like that. They only ask for 2, but there are actually other characteristics of homologous series which you could have easily put in. Perhaps even the physical property. So these are called physical property. So you can discuss those, as I'm sure you have discussed them in classes as well. So because they have similar structure, they also have similar chemical properties as well. So all of these are ester. So they're going to behave like ester. That's why they have similar chemical property, you see. Anyway, the next member of the homologous series is hexyl ethanoate. More difficult to predict the melting point than the boiling point. Why is it more difficult? So in the context of this question, you need to try and understand the melting point here and the boiling point. So what do you see in the trend of the boiling point? I use a different color actually. So the boiling point roughly increase by, I would say, 20 degree maybe. So every plus CH2, the boiling point increased by roughly 20, right? What do you see here? This one is minus 100 roughly. This is minus 80. So this is increase of 20. But do you see that how it increased and then it decreased again? And then it increased and increased. So basically we are saying that not consistent, inconsistent increase or trend in melting point. So actually they're asking you to relate to the table, all right? So the boiling points of the esters in the table consistently increase. So the boiling point increase by roughly 20 degrees Celsius for every increase of CH2 as stated in the table, as I mentioned just now in my discussion. So the next bit obviously is this thing that it increased and then it decreased again. But the melting point does not show consistent increase. For example, from minus 98 degrees Celsius to minus 84 to minus 95. So this is for methyl ethanoate. This is for plus a CH2. This is for another plus CH2. Here we see an increase, but here we see a decrease. Therefore, more difficult to predict melting point. I have written quite a lengthy explanation for a 1 mark question, but really they just want you to look at the table and think about the trend consistency. So this is about data analysis. Again, this is pretty much one of those questions which are suggestive. So you need to be ready to tackle suggestive question if you want to do well in chemistry. A lot of things are not just black and white. I mean, the data itself is black and white, it's in front of you. You need to learn how to interpret the data and make it fit to the observation, yeah? Here they really specifically want you to use how the data in the table. Ethyl ethanoate is a liquid. Alright? So it's a liquid mean it has melted, but it hasn't boiled. So still a liquid at 25 degrees Celsius because it boils at, look at the boiling point of ethyl ethanoate. Boiling point ethyl ethanoate, boiling point 77. Look at the unit, degrees Celsius, 77 degrees Celsius. So it boils at 77 degrees Celsius. You are still at 25 degrees Celsius. Obviously, it's going to take a while before it becomes a gas. That's it really. I've used the data from the table. That is the boiling point. Okay, step 1 used for an ester. So ester are really sweet smelling liquids. You can use it as flavoring. So food flavorings. Some people use it in the perfume industry. Sometimes we use them as solvents, etc, obviously. Okay, not coloring, yeah, flavoring. Okay, because of the sweet flavor, not coloring. So it's organic chemistry. They want the name of acid B. This is the high priority group. 1, 2, 3, 4. 4 straight chain carbon. 4 carbon carboxylic acid is called Butanoic Acid. I'll leave you on the definition of isomer, but basically we are talking about isomer having the same molecular formula but different structural formula. So you can find out the definition of isomer yourself and you shouldn't lose the 1 mark. So the next bit on formation of vinegar from ethanol. So I mean, vinegar is a big scale production. Yeah, I mean, people use it in the food industry on a scale that you cannot imagine. But obviously, I mean, in terms of the chemistry, what you're doing is you are going from the CH3CH2OH to CH3CO2H, and this carbon here goes to this carbon. If I actually draw out the structure itself, and hopefully it should make it clear to you what chemistry we are talking about here. So that carbon goes to COOH there. So this carbon, it's got 2 hydrogen to begin with. This carbon now has no more hydrogen, right? In terms of organic chemistry, this carbon has lost hydrogen in going from here to here. This is an oxidation of alcohol to give you carboxylic acid. In the industrial process of big scale industrial production of vinegar from ethanol, so instead the large scale industrial production of vinegar, actually they don't use chemicals to induce the oxidation. So what they do is the ethanol is oxidized in air, but obviously it's going to be slow. So what happened is, well, when I say in air, it's the oxygen in air as the oxidizing agent. But this reaction will be slow. So these are actually done in the presence of aided or help by bacteria, which act as biological catalysts to speed up the reaction, which speeds up the reaction, the oxidation in air. So this is actually acting as a biological catalyst. All right. Okay. So you can think about this. I think the most common thing is I think in the you have tapai. If you know the Malay fruit tapai, so I mean that's pretty much what's going on. Yeah. Okay. So it goes from ethanol and then it turns into the sour texture of tapai eventually. Anyway, so you want to do ethanoic acid to react with calcium carbonate. You got to get the formula correct first of all. So if I just draw out what is going on, it's a lot easier before I write the balance equation. You should see what is going on. Carbonate reacts with acid to give you a salt. The salt that you get from carboxylic acid is this thing. It is an overall -1, but you want to match it up with calcium 2+, so you need 2 of it. Okay? And you will need water and you will give off CO2. Because you need 2 of that, I must balance the equation with 2 of it. And that gave me my 2 hydrogen atoms there, 2 hydrogen. The oxygen, 1 of the oxygen goes there, and you're left with CO2, the calcium goes there. Now it's time to write they don't need an equation, they just need the formula of the calcium salt. So it's actually calcium and then CH3CO2 twice. Or what you can do is you can write CH3CO2 twice, calcium. Or if you want, you can write CH3COO twice calcium. It really does not matter as long as you get the stoichiometry correct. A lot of people would forget the 2 there because they just assume, they are thinking that the whole thing is 2 minus. Either that, or they are thinking that calcium is +1. And that is ridiculous because calcium is from group 2 and it will do you well to remember that. Name, they want name, they don't want formula. So it's just water and carbon dioxide. So even though I've written the formula in the equation there, but since they want the name, you should really write down the name instead of giving formula.